Hello students, welcome back to my class. Same topic will be continued, circles. In my earlier video, yesterday, I discussed basic concepts related to circle, definition of circle, definition of radius, definition of diameter. We also saw minor segment, major segment, chord, and many different things were discussed. Today I am going to continue the same topic, and today's video is also very useful for class 8th, 9th and 10th standard students. Now I have already drawn some circles on the board and I want to discuss the formulas. Yesterday I showed you how pi was discovered. Pi. We all know that. Yesterday we discussed circumference of any circle. Circumference of any circle divided by its diameter always gives you 22 divided by 7, which is pi. Circumference divided by diameter always gives of any circle. That may be a big circle or smaller than that or a very small circle. Take any circle, its circumference, the length of the circumference, that may be 5 centimeter, 10 centimeter or 15.7 centimeter or 1 meter, whatever it may be, and if you divide that circumference by the diameter of the same circle, then you will always get, for any circle you do this, you will get 22 divided by 7 always, that is pi, which in decimal form we take it as 3.142, right? Okay. Now today I will discuss formulas. Formula, you know, area of a circle, formula is there. Area of a circle is pi r square, and circumference of a circle is always equal to, circumference of a circle is 2 pi r. These are two important formulas. Using these formulas we can find area and circumference. And for lower classes in 8th and 9th standard, especially in 8th or 7th standard, you may get this type of questions, that area will be given, you have to find radius, or area will be given, they ask you to find diameter. You can do one thing, with the help of area, substitute the value of area here, you will get radius, then double of radius, twice the radius gives you the diameter, right? Circumference formula is 2 pi r. They may ask you to find circumference by giving the value of radius, or they may give you the value of radius and ask you to find circumference will be given. Circumference will be given. They may ask you to find radius, right? Or circumference will be given. They may ask you to find diameter. Using this, you can find radius and then double the radius will be diameter again. That is useful in solving that type. These formulas are useful in solving those questions. Now, these are the formulas. Learn these formulas. Area of a circle is pi r square, and circle where r is the radius, and circumference of a circle is always 2 pi r, where r is the radius of the circle. Now, one more important thing about circles is, you have to remember that circles, as the radius increases, area of circle also increases. As the radius decreases, area of circle also decreases. Area means this space. This inside space which you see, this inside space is called area. This boundary, length of this boundary is circumference, and this inside space is area of circle. This inside space is area of circle. So as the radius increases, area also increases. As the radius decreases, area decreases. This circle has bigger radius. This circle has bigger radius, so it has bigger area. This circle has a smaller radius compared to this, so this circle has a smaller area. These circles have smaller than these two. Their radius are, the radius of this circle is smaller than this. So of course this is having bigger radius, bigger area, smaller radius, smaller area. Right? Okay. And now let's discuss tangent and secant. Look at this. I have here a line drawn like this. This line is intersecting the circle, intersect this cut. This line is intersecting this circle at 2 points. So this is called secant. Now many students have this problem that whenever this word comes secant, they don't know what is a secant. Even they have passed 10th standard, they are in PUC, but when the word secant comes, they are unable to recall or imagine what is secant in their mind. Secant is a line. Secant is a line. Secant is a line which cuts a circle or any curved line at 2 different points. Secant is a line which cuts or intersects a circle at 2 different points. Now, what if I draw a line like this? This line is also secant because this line also intersecting the circle at 2 points, one here and the other here. What if I draw like this? This is also a secant because it is also intersecting the circle at 2 different points. What about this one? This is also a secant because it is intersecting the circle, cutting the circle at 2 different points. Secant. This line is a secant. This line is also a secant. This line is also a secant. This line is also a secant. Now what about if I draw a line like this? This line is not intersecting the circle at 2 different points, but it is just touching the circle at 1 point. So a line which touches the circle, at only 1 point is called tangent. This line is called tangent. Here, this is a secant. Here also secant. Here also secant. Because the line is cutting the circle at 2 points. But this one is tangent. Tangent is a line. Imagine if I draw a line here like this. A line here like this, which just touches the circle at 1 point. This line is called tangent. Here this is a tangent to this circle. This line is a tangent to this circle because it is just touching the circle at 1 point. A line that touches a circle at 1 point is known as a tangent. Right? Now question comes, how many secant can be drawn in a circle? How many secant can be drawn? We know that there are infinite number of points on the circle. There are indefinite number of points on the circle. So indefinite number of secants are possible. Now how many tangents are possible? Indefinite number of tangents can be drawn. Because I have drawn, there is a point here. So this is a tangent, it is touching. There is a point here. If I draw a tangent to this point, then there is a point here. There is a tangent here. There is a point here. We can draw a tangent here. So, infinite number of tangents can be drawn to a circle. Indefinite number of tangents can be drawn to a circle. Now, look at this. If I draw a tangent here and a tangent here, suppose these two tangents, these two lines are parallel to each other. These two lines are parallel to each other. It means if you extend them either side, they will never meet each other. These are parallel tangents. Parallel tangents. We can also draw here. If I draw a tangent here, oh, let's see, this is already a tangent. If I exactly take the point exactly opposite to this and draw a tangent passing through this, these two tangents are parallel to each other. If you take a point and draw a tangent to this point and take a point exactly opposite to this and draw a tangent, these two are parallel tangents. So how many pairs of parallel tangents can be drawn? Indefinite number of parallel tangents can be drawn to a circle. Because again there are indefinite number of points on a circle. So indefinite number of parallel tangents, pairs of parallel tangents can be drawn to a circle. We'll discuss more things. Now, students, I have written some questions on the board. These questions, fill in the blanks. These questions are in grade 10, 10th standard mathematics part 1 book. Exercise is I think 4.1 exercise, and main question number 2 is there. Question number 2. These are the questions. First question is, a tangent to a circle intersects it in dash, point or points. A tangent to a circle intersects it. It here refers to circle in dash points. It means a tangent intersects the circle at how many points they are asking? 1, 2, 3, 4, right? Okay, and the second question is, a line intersecting a circle in 2 points is called a dash. A line that cuts the circle at 2 points. A line that cuts the circle at 2 points is called dash. What? You have to write. A circle can have dash parallel tangents at most. A circle can have dash number of parallel tangents, pair of parallel tangents at most, maximum. Then the last question is, the common point of a tangent to a circle and the circle, the point which is common to tangent as well as circle. What is that point called? Right. Now, a tangent, we all know that this is a tangent, this is a tangent, this is a tangent. A tangent to a circle intersects the circle in dash point. It touches the circle at how many points? At only 1 point. So the answer is 1. A tangent to a circle intersects the circle. Tangent intersects the circle, touches the circle cuts the circle at only 1 point. Tangent at 1 point, right? Okay. A line intersecting a circle in 2 points. If there is a line which cuts the circle at 2 points, this line is cutting the circle at 2 points. 1, 2, at 2 points. What is this line called? I have already explained, right? Suppose a line, there is a line, imagine there is a line, cuts the circle at 2 points. 1 point here and the other point. So this line is called dash, secant, right? Secant. And then a circle can have dash parallel tangents at most. How many parallel tangents, maximum how many parallel tangents can a circle have? We have drawn here, right? We can draw like this, we can draw like this. Because there are indefinite number of points, so indefinite number of tangents are possible. Therefore, indefinite number of parallel tangents are possible. So indefinite means infinite, means uncountable. Indefinite means infinite, uncountable, we cannot count. So many are the uncountable number of parallel tangents can be drawn to a circle. Okay. The common point of a tangent to a circle and the circle. The common point, this point, the point at which, let me draw it clearly. The point, this common point, the point at which the tangent touches the circle. So This is common point. Common, why common? Because this point is a point on the line as well as on the circle, right? That's why it is called common. This point is common here. Not here. Here. There is a common point. This point is of the line as well as of the circle. It's common. So the common point of tangent and circle is called point of contact. Point of contact. Point of contact. So these are the questions, and this was another small video on circles, basic concepts of circles. In my next video, I am going to explain the theorem that is in 10th standard, and that theorem is very important. Two theorems are there. More I will discuss one, and the next day one more will be discussed, and we will also solve problems that are in SSLC Part 1 Circles lesson, right? Hope you all understood the video, and I want you to subscribe to our channel, like it, watch it for watch it more, so that our watch time increases, right? I want you to watch the video again and again and share with your friends and relatives, and don't forget to subscribe the channel, and don't forget to comment and tell me how you like the video. Thank you.